Venn diagrams. A Venn diagram consists of a universal set U represented by a rectangle, as you can see here. So when we do our universal set, that's the big rectangle. Any subsets within it are generally represented by circles. So you can see here, like we have a subset A. So A is a subset of the universe. Everything in A is right here we get colored white. Everything that's not in A, right here is colored like a lime green or like a olive green. That we call the complement of A. So it's everything that's not in A but in the universe. So here's our universe. Here's everything in A. Everything not in A is over here. It's the complement of A. That's why it's A prime. Subsets. So right, we know if B is a subset of A, then every element of B must also be an A. So how do you do that with Venn diagrams? Well, it'll be a smaller circle inside a bigger circle. So you have the universe, then you have a subset of A, then you have the subset of B inside of it. If two sets are intersecting, if they have common elements, so if A and B share some terms, then that's where they overlap. The overlapping part would be the common elements. Intersection. So right, A intersection B consists of elements common to both A and B. So remember, this is where they have in common. So that's the little part right there. That's where the circles overlap. The union of A and B. So remember, that's everything that's in A or B. It's in either of them. So it's everything in A or B or in both of them. So that's everything. So very important. Intersection is what they have in common. So it's only where they overlap. The union is what's in either of them. So it could be an A, it could be an A, it can be B, or it can be both of them. So that's how they're shaded. And if they're disjoint, if they're mutually exclusive, that means they have nothing in common. So they're two separate. They're not intersecting at all. Okay, let's do some examples. Suppose our universe is 1 through 8. Illustrate Venn diagrams for the following sets. So we're going to do each one. So here's A. This is probably an easier way for me to do that. There we go. Look at that. There's my union. My universe. Remember, my universe is the numbers 1, 2, 3, 4, 5, 6, 7, 8. Then I have A and B. Now, first I'm going to decide if they're intersecting or not. And look, they do share some common elements. So I'm going to draw them intersecting. And do the same thing with that pretty circle. There we go. This one is A, and this one's B. Now keep in mind, A is this whole circle, not just the outside. B is this whole circle, not just the outside. So A is the whole circle here, B is the circle there. A has 1, 3, 6, 8. B has 2, 3, 4, 5, 8. So they share 3 and 8. So that's what's going in the middle here, because they both have those. Now A also has 1 and 6. And B also has 2, 4, and 5. Now, is there anything that's not in any of these that's still in the universe? Remember, the universe is 1, 2, 3, 4, 5, 6, 7, 8. So 1 there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there. There's no 7. Nobody has 7. So that means 7's on the outside. 7's not in A or in B. So 7's out there. That's a funky 7. It was like way bigger than all the rest of the numbers. So 7's out here. 7's somewhere in the universe that's not in A or in B. And that's my Venn diagram for A. B, same idea. Let's make a rectangle. Okay, well, whatever. And then before I draw my circles, I don't know if they have anything in common. So they do share a 3. That's all I need. And a 6, I think. But we'll focus on 3 first. Make that a little bigger. There we go, that's fine. So we have our A and our B. Again, I like to find out what they have in common first, so I can put it in the middle. So 1, 3, 6, 7, 8, 3, 6, 8. So 3, 6, 3, 6, 8. So it looks like actually B is a strict subset of A. Like B I can actually draw inside of A because there's nothing else that's outside of it. I could draw like this and just put 3, 6, 8 here. And then leave this side blank. That does work. And if I did that, on the A side, it would be, 1 and 7 by itself? And then on the outside, that's an ugly 7. My 7s are not very good. That's a little bit better. On the outside, what's missing from all that? It looks like nobody has a 2. So I'll put that on the outside. Nobody has a 4, a 5, or that's it, 4 and 5. So 2 and 4 and 5 are all on the outside. So they're not in A or in B. So that does work as a Venn diagram. Now knowing that 3, 6, and 8, that B's a strict subset of A, I might just draw a big circle like this, and then like a smaller, let me expand that, and then a smaller circle inside of it, where this is B, and that has 3, 6, 8. And then here is A, and that has 1 and 7. Right, because that shows you that A has 1, 3, 6, 8, and 7, and B just has 3, 6, 8. So this one's all engulfed in that one. And then on the outside you have 2, 4, 5. So that will work also. And then if I was going to do C, 2, 4, 8, 1, 3, 1, 3, 5, you can tell you can see right away they have nothing in common. They're just joint sets. So if I was going to do C, let me erase this one. That's the first one right there. If I was going to do C, it would be 2 disjoint sets. So A and B. A has 2, 4, 8. B has 1, 3, 5. It looks like nobody has, let's see, 1's taken to 7. 7 and 6. So 7 and 6 are on the outside. So the 7 and 6 are neither in A or in B. Suppose U equals the positive integers that are less than 30. R are the primes less than 30, and S are the composites less than 30. List the sets of R and S. So I'll start with R. So prime numbers less than 30. So usually 2 is the first prime number, then 3, and then 5, 7, 11, 13, 17, 19, 23, 29. I believe those are all the prime numbers less than 30. Remember, prime just means the only factors I have are 2 in itself, or 1 in itself. So 2 has 1 and 2, 3 has 1 and 3, so on. The composite's less than 30. Well, that sucks. That's all the rest. So composite numbers less than 30. So like 4, 6, 8, 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25, 26, 27, 28. Less than 30, so I don't include less than 30, so I don't include 30. So like that. Right? So composite numbers are just numbers that have more than one. That's not basically not prime. So we have those numbers right here. Find R intersection X. So B is R intersect S. That would be the empty set. These are opposite things. So we have that. R union S, well, I don't even want to write that, but it's basically all the numbers from 2 to 28, right? 1's like a funny one, it's not prime, it's not composite, and then 30 because they said less than 30, but 30 is in the universe. So I'm just going to say, I'll do this, I'll say X is a positive integer where X is between 30 and 1. I'll write it that way. Since I don't want to write all these numbers, so I'm going to write it this way. So X is between 1 and 30, but it's not 30, it's not 1. So there we go. C represents the set R and S in the Venn diagram. So I was going to do that. Here's R, here's S. I'm just going to put prime less than 30, and I'll put composite less than 30. And then my universe is Z plus, where X is less than 30. So the only thing that's, like I kind of talked about here, the only thing that's not in either of these is 1 and 30. So that's on the outside. So everything in R is the prime numbers less than 30, which is this set. Everything in S is all the composite numbers less than 30, which is this set. And the only thing that we haven't counted is 1, because 1's kind of funky. It's not prime or composite. And 30, because these both said strictly less than 30, but 30 is in the universe. So there we go. 9. So the Venn diagram consists of 3 overlapping circles, A, B, and C. List the letters in each set. So using this Venn diagram, we're going to list all the things that are in this set. So look at A. A, so I just want all the letters that are in A. So remember, A is this circle. right? So all the letters in A are H, J, P, B, sorry, A, D, C. So H, J, B, A, D, C. So that's everything in A. B, it would be this one right here. So it's all those. So B is all of this. So C, D, A, G, K, F, E. I should write commas between all of them, but C likewise, and hopefully by now we understand that, right? C is all this. So C would be B, A, F, E, I, and J, I, and L. So there's my ABC. And then let's get to the more interesting ones. A intersection B. So where is that? So I want to intersect A with B. If you look at it, that is just this portion right here. That's where A and B intersect. So it's CDA. How about A union B? Now remember, union means it could be in either one. It could be A, it could be in A, it could be in B, or it could be in both. So the union is actually all of this. It's both of those put together. That's my union. It's A union B. Anything that's in either one gets put in there. That makes it harder here, so I'll put 5 down here. So that's H, J, B, C, D, A, F, E, G, and K. Right, so again, it could be in A, it could be in B, or it can be both of them. So that. Move on to the next one. B intersection C. So where does B intersect with C? So that should just be right here. Right? That's where B, and C intersect. So AFE. Like that. And then the final two down here. A intersection B intersection C. So I know where they all intersect. So if I had A, is all of this. C is all of this. And B is all of that. Where's the portion where you see all 3 colors? Like where do they all intersect? And that would just be right here at A. That's where they all intersect. The one spot where they all cross is A. Now when you go to 7, or 8 I should say, I want the union of all that. Remember, union means either it's in A, or it's in B, or it's in C. It's in any of those. So that's actually all the circle. That's all the letters, right? It could be any, because there's nothing on the outside here. So it's any of those letters. I mean all those letters. So it's H, J, B, C, D, A, G, K, F, E, I, and L. Right? It's everything in all the circles. That's what the union stands for. Okay, last couple. Suppose A and B are disjoint. Shade on a separate Venn diagram the following. So I'm going to cheat a little bit since I could just erase. I'm just going to do them all on here. Sorry for people taking notes at home. You might need to make lots of Venn diagrams. So the first one, I want to shade A. Easy enough. There's A. Done. B, I just want to shade B. Well, same thing, just shading B. Probably don't need to shade both of these if you understand that's the first one. Okay, and this is what gets more interesting. This is what we're here about. What's A prime? So remember, that's not an A. So I like to think about it this way, right? So this is A, but that's not what I want. I want not A. So I want everything else. So not A would be all of this. Not a very good shader here. Anyway, like that, right? It's everything except for A here. Actually, I should erase the thing I did there. Right, so that is not A. Right, you have A, and you shade everything else. Not B, same idea. Right, so you're like, hey, this is B, but I don't want that. I want not B, so it'll be everything else. So do a worse job here, but like that. So there we go. A intersection B. Well, in this case, there's nothing to draw because they don't intersect. Normally it would be on a normal Venn diagram. A intersection B would be where they intersect. It would be this. But on this one, there's no intersection. It's an empty set, so I can't draw that one. A union B still works, because remember, union means either. It's or. It's an either statement. It could be in A, or it could be in B. So that still works. Even though they don't overlap, you just go to A or B. It's in one of these two. Done. Okay. Then these get even more interesting. And I actually might do these separately because I want these to stay up here. So there's my box. Here's A. And here's B. My circle was so bad it didn't classify as a circle. Okay, something like that. I should move this. There we go. Because remember, they don't intersect. So I want the intersection, very important intersection, of not A and B. So let's draw not A up here. Not A is all of this. Remember, everything that's not an A. I'm going to do that in purple. So with the intersection of that and B. So let me draw B. I'll do B in orange. So I want where those two things intersect. Right? Where do they intersect? Where I cross-shade? Well, actually I cross-shaded just in B. It's kind of hard to tell because all you see is B, but like that's where it has both colors, right? The purple is all of this, everything, and then I recircled B, which was orange. So that's my answer here. It's this guy. That's everything that's not in A. So not in A, but it is in B. So it just happens to be B. And it wouldn't be that if it was a different Venn diagram picture, but in this Venn diagram picture, it happens just to be that. Okay, the next one. Let me erase this one. Sometimes my rectangles are so bad, I'm just not even going to try anymore. A, B. Again, let's use this. I'm going to use this top one as like my training ground. A union B, right? So A or B. If it's in either one. So let's first color out each one. So A would be this. And then not B. So again, this is B, not B. Let's do in purple, I guess, again. So not B. Now, unlike the last one where I said the answer was the intersection, so where they overlapped, so it'll be A. This one says either, so it's where there's any color at all. So it's essentially everything except for B. It's essentially just not B. So my answer here is this going to be that. Right, so it's A, union, not B, which is everything this. Remember, union means either. It could be, as long as there's a color, you take it. So it's all this. That looks like my nephew drew it. Okay. And then let's go I. So this is going to be interesting because notice how the prime's on the outside. So it's basically saying I want you to do A intersection B, but then the prime of that. Now it's kind of weird, especially with this picture here. So A intersection B, remember we did this earlier? This was like the empty set. We couldn't draw it. So there's no value here. So what's the opposite of that? Well, I guess it would be the whole circle, the whole thing, the whole universe. Right? Opposite of nothing is everything. Sounds a little weird. But it's because A intersection B was nothing. The opposite of that composite, that would be everything else. Okay, let's try another one. I'm just a little faster. So A, well, A is just what it says. A is all this. A is a big outside circle. Not this though. This is the A. There you go, done. B, as you can probably guess, just the inside. Done. Down there. Not A. So again, I like to draw this out. So let's figure out what A is. A is all of this. Right? A is that Venn diagram, that circle right there. So I want not A. I want everything that's in the universe but not in A. So that would be everything outside that circle. So that would be not A. Something like that. Not B, the next one. Similar idea, right? B is only this part. I don't want that, I want not B. So that'd be everything outside of it, including some of A. So there's not B. A intersection B, so it's a little weird. What do they have in common? What do A and B have in common? But B's inside of A. So it actually turns out just to be like, this is the thing I did before. Here's B in yellow, and then in orange I'll do A. Where do they overlap? Right here. In B. It turns out to be B. A union B, if you tell what that is, right? It's in either A or B. Well, that just turns out to be A. Again, this is not always the case. It's the case in this one context because B is a strict subset of A. So it turns out this way because they're subsets of each other. Ooh, as always, let's get interesting. A prime, not B. So again, these are generally more interesting, and so I tend to draw them on the side here because it also just helps my thinking. That's how bad of a rectangle I drew. So here's A, and then here's B. A little scratch work because I gotta think about this. So I want not A. So let's do that in yellow. What's not A? It's not an A. So it should be all this stuff outside of A. Like that. And then I want to intersect that with B. So B, I'll do it in orange. It's right here. Besides my bad coloring, they don't intersect at all, right? A's not A is outside the big A, and then B's on the inside of A. So they don't intersect at all. So this is the empty set. I can't draw it. In the case, how do you draw a picture? Will be like this. Be not colored, not shaded. That's all you can do. Okay, let's talk about H. Okay, still suck at drawing rectangles. So A, B. Again, let me get my scratch work out here again. So I want A union B. So remember, union means either. So let me draw A. Let me color in A first. So that's my A. And I want union with that with not B. So this is B. Not B would be not that. So let me do like a light green. So everything that's not that. Right, so it's all that. Now remember, this is a union, so it's either one. So you just take out wherever there's color. And it looks like I have color everywhere. So it's going to be the whole map. So remember, it is an either or, right? So either or just means wherever there's color, that's your thing. I want A, I want not B. I want either one. So you get all that. Okay, last one, I. So here is A, and here is B. And just like last time, I'll do my little thing here. So look what it wants. It wants the intersection of A and B. Now remember we talked about that earlier. Intersection of A and B just happened to be B. So this is my intersection. Again, it changes depending on what the picture of the Venn diagrams are, but in this case, it just happens to be B. I want not that. So I want everything that's not that. So I want everything outside of B essentially. So it'd be everything like this, not including B. There we go. That's the lesson.